Hi, today we are going to discuss an important system design pattern, that is deployment patterns. So you must have heard about the term CICD, like which is called continuous integration, continuous deployment, also continuous delivery. So in any kind of modern applications, the waterfall model doesn't really work very well in my experience also, because you are not exactly incrementally building and delivering features at the same time, right? You obviously cannot keep your customers waiting for 6 months or 10 months to release a new feature. What they want is kind of an incremental delivery of small features so that they are engaged in the product, right? And which is where this entire concept of continuous integration, continuous delivery and deployment has come into the picture, right? But now to do that, it is not easy, right? And it is one of the most best practices and the patterns that is leveraged in real world by almost all companies today, definitely by the FANG companies. So we are going to look at the deployment patterns and what are the strategies to take, when to take, what to take, and what are the use cases that it solves, right? So let's get started. So what is continuous integration? Basically, continuous integration means that you want to implement code and regularly merge the code to a central repository, right? You don't want to, like I mentioned, don't want to stand by for developing a huge amount of code and then delivering everything in the production after say 6-10 months, right? That is not what we want to do. We want to continuously build, right? And then what is continuous delivery and deployment? It basically means that once the code is merged, you automatically build, test, and prepare it for production release, right? So you're continuously implementing something, you are pushing that code to a central repository, it gets automatically deployed to your services, test happens automatically, it gets prepared for production release and gets released to customers, right? That's continuous integration. So you don't have any manual intervention in that complete deployment process, right? So now there are multiple patterns that we are going to discuss. So we are going to discuss the recreate pattern, ramped pattern, which is also called incremental pattern, rolling update pattern. Then we have the blue-green pattern, which is also called the red-black pattern. Then we have the shadow pattern, A/B testing pattern, and canary patterns, right? A canary pattern is one of the most and one of my favorite patterns. So we are going to discuss that at the end of the video, because we are going to also going to share a fun fact about the canary deployment patterns. So let's get started with the recreate patterns. So in recreate deployment pattern, what does that mean? That basically means that whenever you're deploying, you have the current version of your service, and then the new code becomes the new version, right? So your previous version is terminated first, and then the next version, that is the new version, is rolled out. So let's see how that happens. So this is your initial state where a user is requesting through your load balancer, API gateway, whatever it is, and it is coming through to your service, and the service is currently holding the version 1 of your application, right? Now during deployment, you take down your system, you take down your application, requests are not getting served, so basically it is going through a downtime, right? You are probably having a maintenance window or something like that. And then in the final state, you bring up the service with the new version, that is the version 2, right? That is the recreate deployment pattern. So you basically, during deployment, you shut down the service, and the new version is rolled out after the previous version is completely terminated. So what are the benefits? It is simple to do, it's not very difficult, it's straightforward. You don't have to manage multiple application versions, like you are not managing the version 1 and version 2 at the same time, right? It avoids any backward compatibility challenges, because when you are rolling out version 2, you are not maintaining version 1, so you don't have to basically uh, understand a way how the users are going to whether the behavior is same in both the versions or not. Obviously you want to be backward compatible to the usage, but since you're not maintaining both the versions at the same time, it's not at that point of time that you are worried about the backward compatibility. You have already tested everything, new version is ready to go, and it's already live, right? But obviously, as you can understand, there are a lot of drawbacks. Definitely one of the drawback is that it requires downtime. In today's modern applications don't require downtime. I mean, they always try to be 100% available. That's not a feasibility. So as much 99.999% availability or something like that is what they require. So you cannot bring down, say, an application, right, like Facebook.com or Amazon.com. You cannot bring down those services, right? And it is not, like I mentioned, it's not suitable for highly available or mission critical systems, right? The next pattern is the ramped deployment pattern. In the ramped deployment pattern, what we do is we update a subset of the instances at a time, right? In the previous pattern, we completely shut down the application. Here we do it a subset by subset by subset of the application, right? So let's say this is the initial state that we have. And during deployment, what you're seeing is we have taken down one of the clusters or one of the service tasks, right? And moved that to version 2, right? So we have deployed version 2 in one of the clusters, and the other cluster is serving version 1 traffic still, right? And then in the final state, you are deploying the version 2 in all your clusters or all your environments, right? So that is the RAM deployment, which is a rolling update deployment, right? Benefits, yes, there is no downtime and low risk, because while you are taking out a subset of your instance or your environment to a new version, uh, customers are still able to serve traffic from version 1, right? So it's low risk, and are not having any downtime. It's at real time, and it minimizes any impact, right? If the new version has bugs or it is unstable, you can obviously, you already have the version 1 up and running in one of the instances, you can flip the other instance to also load version 1, right? Drawbacks, the deployment is slow because you have to, like you can understand, you have to do it subset by subset. And here, for the sake of the discussion, I have showed two clusters. In a real world example, there might be tens of tens and hundreds of clusters, right, or service environments. So it is slow. You have to manage both the versions at the same time, which was a benefit in the previous deployment, right? You have to manage the overhead, and there is maintenance cost also, and your rollback is slow, right? Because if a customer has gone to version 2, if you are serving traffic from version 2, if you go back to version 1, that means that part of that feature is no longer available, right? So rollback also requires intimation to customers, so that is difficult. So that's a drawback. The next pattern is a very famous pattern. It's called blue green deployment pattern. It's also called red black pattern in some of the scenarios. But basically what it does is, the new version is deployed alongside the previous version, right? So the entire new version is deployed in a separate environment without touching the first version, or the initial previous environment, right? And both the versions are up and running, and then the traffic is switched from one version to another version, right? So you do a cutover from your previous version to the next version. So let's see how that happens. In your initial state, you have this, which we are calling the blue, which is the initial version, right? During deployment, you are deploying your version 2 in a completely new environment, right? Which is the green environment. And you, at that point of time, while the deployment is happening, you have your blue and the green environments completely up, right? But the green environment might not be serving any traffic. And in the final state, you are completely doing a cutover of the traffic to the green environment, and the blue environment is no longer present, right? So that is the blue green deployment or the red black deployment. What are the benefits? No downtime, because we are obviously serving the traffic during deployment. No shared resources, it is completely independent. Rollback is easy, right? You are maintaining two environments completely. If there is any problem, you can obviously go back to your previous environment or previous version where the previous version is deployed. What are the drawbacks? It's costly because you are basically maintaining the entire environment twice, or depending on how your system is, more than one time. And the cutover needs patience, planning, precision, right? I mean, you have to decide when you are cutting over the traffic, you are doing the switch. At that point of time, you have fully tested, you are fully 100% confident, right? So that's a criticality. But that requires planning, but that is it requires time, but that is more safer also, in my opinion. The next pattern is the shadow pattern, a shadow deployment pattern, where you are mirroring a request and replaying that same request and executing it in another environment, right? So let's see how that happens. So basically, your user is requesting for some data, it is calling some service, and you are basically segregating. What you are doing is you already are serving your production traffic through version 1, right? But you have in parallel also deployed version 2, where you are replaying the production traffic in version 2 also, right? So basically you are making a shadow mechanism. So the real world scenario where the real world request is coming, you are also trying to parallelly, you are not without disturbing the customer traffic, because it is already being served in the production environment, which is version 1. You are also testing it parallelly in another environment where you might have deployed some new feature, right? And that is the main benefit. One of the, like, there is no production impact, and new feature testing is very easy. Like whenever you are doing any kind of a feature rollout, a shadow testing mechanism can work very well, right? Basically you are running the entire production on a shadow environment to verify, say, backward compatibility, right? And that is why it is low risk. However, there are some drawbacks, and the drawbacks are a bit costly also at times. First of all, definitely it is costly because you, from a maintenance or from a service perspective, because you are maintaining that entire overhead, you are maintaining two versions at the same time. You have to you have to have, obviously, a lot of operational and management overhead, like I was saying, because in version 2, whenever you are replaying that same traffic, it can be synchronous. I mean, the moment it comes and serves in the production environment and goes to version 1, at that point of time, in that request path itself, you can also invoke the shadow traffic. But you can do that asynchronously also, right? But that decision is difficult, and you have to obviously maintain and manage, and basically the point number 3, which is talking about, you have to be very cautious, right? In some kind of systems, you don't want the users by mistake, if you have a code bug or something like that, you don't want the same request to be served 2 times, right? If you are changing a state of the system, right? For example, in payment systems, you don't want by any way, by any mistake, that the customer is paying for the same thing twice, right? Some way, if it is integrating with third party, if your second version is integrating with any third party applications, so those can be really painful and can also lose customer trust. So whenever you are doing a shadow deployment pattern, you have to be very careful, and it is primarily used for testing, so you should be able to do that with production traffic, but already after serving. I would recommend, do that asynchronously also, not in the code path which is executing the production traffic already, so that you, and that has multiple benefits, because you don't want to add latency, you don't want to cause any kind of a code bug in that path itself. So a sync mechanism, in my opinion, is better. The next deployment pattern is the A/B test pattern. So it's similar, but you filter the production traffic conditionally on another environment. So in the previous pattern, what you did was you were mirroring that same request and replaying that execution in your new environment, right? In your new version. But here you are filtering the traffic based on certain criteria, right? So which is the real time production traffic. It's not that you are actually playing it on a shadow environment. It is the real production traffic, and you are filtering based on certain criteria. So let's see how that looks like. When the request comes, you have both the versions up and running. Version 1 is still serving the production traffic which was there in the previous version, but say you have implemented some new feature, right? And you want to test that part, which can be based on a customer usage, or say from where the geolocation, or from IP address of a customer. Those kind of use cases, those kind of criteria, you can use to bifurcate and segregate that traffic and move it to version 2, right? So you are basically filtering the production traffic. It is not that the same traffic is not being played, the same request is not being played in version 1 and version 2. Is different request, it's both live requests, but based on certain conditional criteria. What are the benefits? Definitely it is very good for testing, it is very good for uh, measuring a new feature. If you want to release a new feature, is very good, and you can also see whether that new feature, you can actually bifurcate and filter the traffic based on the new feature, and then you can verify whether the new feature is working in version 2 or not, without impacting the main production traffic, or which was already working in version 1, right? So you have a control, the deployment is controlled by you. Drawbacks, this requires, yes, you are playing with real production traffic. It requires a lot of governance and monitoring. You need to be able to monitor the entire traffic, entire request, all the environments. So you have to be very careful there. And the filtering criteria, I mean, also the duration. Say if you are releasing a new feature, you are doing that based on certain criteria, right? So now what happens if all the users fall in that criteria, and you at some point of time you all obviously want to move 100% of your traffic to version 2, right? So that process can be very long, right, to validate that it is working for 100% of the traffic, right, now for all the use cases that you have built. So those are some of the drawbacks. And now coming to the final deployment pattern, which is one of my favorite pattern, it is called Canary deployment pattern. So before we go to the Canary deployment, like I said, I'll say a fun fact. So the Canary techniques, right? The Canary release techniques, these were inspired by, in the early days, the in coal mines, right? They used to use canary birds as a alert mechanism, right? Basically to alert whoever the coal miners were, if there was any toxic gas that reached out of dangerous levels or something that happened, right? So basically what they used was, they used the canary birds. If there was a gas or there was some kind of a hazard that happened, the canary birds would get killed, which is, yeah, it is bad, but canary birds would get killed before the miners, right? So the miners would get notified that the canary birds are getting killed, so there is some kind of a hazard that has happened, so we have to go out of the mine or evacuate or do something. So that is the canary mechanism, right? And that is what canary deployment pattern also is. So basically you are gradually shifting production traffic based on certain percentage, right? So initially you have your version 1. During deployment, you are basically segregating the traffic in the by a percentage. You might want 90% of your traffic to be served by version 1, but 10% of your traffic you are moving to version 2, right? It is a phase wise incremental deployment. Now that is very important, and one of my favorites, because this actually helps to validate a lot of things. And in the previous deployment pattern, like A/B test pattern, you are filtering based on the feature that you have developed. But here you are filtering the entire traffic, right? It's not based on any feature. So you might have developed something, but you are selecting 10% of the traffic, out of which maybe 5% of the traffic is based on your new feature, but that doesn't matter. You are basically cutting over 10% of real-time production traffic to your version 2, right? And then in your final state, the entire version 2 is live, right? So this gives a very good control to the teams and the service teams who are owning the deployments. And definitely one of the benefit, no downtime, as you can understand. You can the second point is one of my favorites. Like, you can actually verify with live production traffic, not just based on the feature. So it acts as a backward compatibility testing. You can do a lot of things using Canary deployment patterns, right? And rollbacks are also very fast. Like, if you have only 10% of the traffic, 90% is already on version 1, you can easily roll back. For these kind of mechanisms, you basically use a flag based or a config based mechanism, where you can just flip a flag and the deployment is traffic is routed to the to another environment. So which is very fast, can be done quickly. So and also, if you have to roll back not only say a version to the entire environment, if you have to roll back the code or say some part of a bug, so those things can be done. Or if you're releasing a feature, that feature itself release can be under a feature flag, right? For example, what are the drawbacks? The rollout is slow, right? When it's similar to A/B test pattern, the reason being, you are doing a subset of the traffic, that is 10%. By the time you are completely you have moved the completely entire 100% of the traffic to the final state, to version 2, it is going to take time, right? Which basically also means that while you are playing with live traffic, you have to definitely maintain governance. You have to govern, you have to monitor, you have to be very careful. If there is something that is breaking, because you are obviously working with live traffic, you want to immediately roll back one of the mechanisms that is used by a lot of companies is you roll back first and then postmortem, right? You don't try to figure out what is happening and why is it failing at first. You first roll back and then start the postmortem of the analysis. And one of the risk is backward compatibility risk, is because whenever you are deploying version 2, when the traffic is hitting version 2, it might be difficult to understand, depending, I mean, what is a feature that you have developed, whether that it is backward incompatible, because you are not doing kind of a shadow, right? You cannot, it's very difficult to measure, right, whether backward changes are working. So which is where another thing that folks do, that the 10% traffic, that 10% is one of the ways that can be done is not exactly product, I mean, it is production traffic, but it's not exactly production customers. What we can do is we can actually create some fake customers, right, test customers in actual production environments, right, and do the exact same things that customers do to verify, and you then shift only that percentage which are your test users, but in production, right, they are basically mimicking what the entire real world use case that real world customers are using, right? So that is how they I mean, some of the companies solve the backward compatibility risk. But yeah, I mean, that is obviously a drawback if you are not able to make new users. If you want to create new users, that obviously means new resources, which can be costly. So yeah, these are some of the drawbacks. But yeah, definitely Canary deployment, and whenever you're doing a high grade mission critical systems, not one deployment doesn't always work, as you have seen through all there are 6 different deployment strategies. You can mix and match, like blue green deployment is also very nice, but it can be costly. RAM deployment is also any like a gradual rollout, it can be slow. So there are pros and cons. A mix and match of all these patterns will definitely solve any of the use case or any questions that you might get in your system design interview or in your real life world, right? So these are the deployment patterns. Hopefully this was useful.